Hello, it's day 7. I got a piece of candy. I'm gonna eat that. Let's let's do some having a code. We got day 7. Haven't looked yet. Don't know what it's gonna be about. I'm gonna be talking through chewing for the first 20 minutes in this video. Just kidding. It's just kind of a gummy. Let me reset things. It's day 7. Back to how we do it. This is what I do behind the scenes after every video. So sick. All right, we're going to take a look. This is 1 week. If we can do this, I'm going to feel really good about myself. I'm going to sleep easy. We'll see if I do 8 through 12. I don't know. Probably not. It's kind of nice just calling it a week, calling it quits. But I encourage you, if you want to do 8 through 12, I can use the template in the description if you like, or you can do it on your own computer. But definitely share the videos if you do record how you solve it. That'd be really cool to see. All right, let's dive in. Let's see what's going on. Ooh, laboratories. You thank the cephalopods for the help and the exit the trash compactor, finding yourself in the familiar halls of a North Pole research wing. Based on a large sign that says Teleporter Hub, they seem to be researching teleportation. You can't help but try it for yourself and step onto the large yellow teleporter pad. Suddenly, you find yourself in an unfamiliar room. The room has no doors. The only way out is the teleporter. Unfortunately, the teleporter seems to be leaking magic smoke. Since this is a teleporter lab, there are lots of spare parts, manuals, diagnostic equipment laying around. After connecting one of the diagnostic tools, it helpfully displays error code "Oh no," which apparently means that there's an issue with one of the tachyon manifolds. Quickly locate a diagram of the tachyon manifold, which is our puzzle input. A tachyon beam enters the manifold at the location marked S. Beams always move downward. Tachyon beams pass freely through empty space. However, if a tachyon beam encounters a splitter, the beam is stopped. Instead, a new tachyon beam continues from the immediate left and the immediate right of the splitter. Oh, wow. For example, in this example, the incoming tachyon beam extends downwards from S till it reaches the first. At that point, it goes left and right. Okay, cool, and it stops. Keeps going, splits. This point, two splitters create a total of only 3 tachyon beams, since they are both dumping tachyons into the same place between them. Process continues until all of the beams reach a splitter or exit the manifold. To repair the teleporter, you first need to understand the beam splitting properties. In this example, the beam is split a total of 21 times. So we're kind of moving this thing and we're detecting how many times a beam is split. Very interesting. Cool. So we're counting splits. We're not counting like how many end up at the bottom. We've got a crazy diagram. This is wild. Looks like a giant Christmas tree. Cool. So what we need to do is figure out an algorithm that is going to work with this. Let me copy the puzzle input. And let's dive into it. Let's see what we can do. So this is the string. We've got new lines. I've trimmed it, so we're going to get rid of this white space. What I want to do is kind of figure out the offset of these things. Figure out which row we're in. So I think for each row, I just want to know like where are the beams. I think that would be good data to have. And then I can start with a beam at S and say, if you do a hit, do n minus 1, n plus 1, add that to the next like set of beams, and keep going. So let's see if that works. All right, so I'm going to start with this string. I'm going to turn it into a bunch of lines. So now we've got everything broken apart. What I want to do is turn each line into a bit of data. All right, so what are we going to do? To information. Given a list of strings, what information is useful to parse out of this? So I'm going to start by saying I would like to know. I'm gonna use a type list here called index, so I remember that this is 0 based. So we're gonna have a start index. And I'm gonna do that trick that I did the other day so that this is all centered on the screen, even after I format. And then what I wanna know is I wanna know for each row, I want kind of a list of rows. And the row is going to be a set of indexes where I find splitters. So I'm just going to make that a record just for clarity. And let's import set. Oh, we already have set. Okay, to information. And I'm going to take our lines. And I'm going to say case lines of first and the rest. I want to do is say string dot like get index of. I wonder if there's a string extra package. This might have like a get index. String index, get two sentence case. Oh, these are a bunch of like helpers for this. Maybe I'll just turn stuff into a list and then use that. Oh, this is going to be day 7. Save that so that I can share it in the description of this video. Okay, so what I want to do is I want to get index of S. So if I have a single index, then I know I'm in a good shape. Start. Then I can keep going. But if I have more than one or I don't have any, this is going to be a problem. So what I'm going to do is I'm going to return a maybe just for clarity. Maybe I'll return a result. A result is like a way for me to say like what went wrong. Found more than one S. Otherwise, we'll keep going. I'm going to do like a little to do here. Okay. So that's good. Otherwise, this is like unexpected line count. Yeah, I'm just gonna do a maybe because I don't want to keep confusing myself with like, I don't want to like keep having to think about error cases. This is like for invalid input, and we know that our input's good, and this isn't like an actual program that's going to be out in the wild where we have to constantly wonder if the puzzle input's invalid. Cool. So if I have the start index, let's assume this function exists. What it does is it takes in a single, I guess we'll ask for a character. And what we're going to do is we're going to give it a character, give it a string, and it's going to give us a list of the indexes that found it. So the way I can think to do this is if I take the string, turn it into a list of characters, what I want to do is list.indexed map, take the index and the character. And then I'm just going to say if C equals the char that we passed in, then return the index, otherwise return nothing. And then we're just going to use this filter map identity trick to turn the list of maybe indexes, because you turn maybe numbers, into a list of indexes. So I'm going to do compile. It's going to be like what's to do. So let's see if we can get away with this. Information, start, and let's just have no rows. Great, start 7. So it's saying at index 7, 0, 1, 2, 3, 4, 5, 6, 7. Perfect. Next, we're going to loop through all the remaining rows. List.map through all the remaining row strings. And we are going to get the indexes, the indices of caret for that row string. And then we're going to use set dot from list to turn that into a set. We're going to pass in the rest of the lines here. I'm just going to call that rest of lines. And my multi-line formatting is goofed. It's really you. Oh. Oh yeah, that's right. This is going to be splitters equals. Cool. So this is going to be a list of a bunch of empty sets. I almost want to just like get rid of the rows that aren't split, but I'm going to keep it around for now. So what we're going to do is we are going to loop through all these rows, starting with like one laser at 7. And if we find a match, we're going to basically add to our set of indexes lasers. So we're gonna do, if this all went through okay, maybe .map simulate. And so simulate is going to take in some information as its argument, and it's going to return, I guess, a set of indexes. That's going to tell us, I guess simulate, I need to keep track of how many times there was a split, right? Simulate. Okay, count splits. Info. What we want to do is we want to say take all the rows, list.fold L, I'm going to call loop, and then initially we're going to say the count is 0, and we're going to say I'm going to treat the lasers as like a set of indexes. So this is going to be lasers, or beams, I think is what they called it. And I'm going to say just a single, you could do from list info start, or you could do set.singleton. But what this is going to do is this is going to take in each row one at a time. It's going to take in this state. So just like before, let's make a nice type alias for this. Type alias state. The count is what we're interested in. And the beams is going to be a set of indexes. It's going to initialize with just the start index. So we're going to kind of loop. We're going to update the state. We're going to return the new state. And then when we're done with all this, we are going to return just the count. We're not interested in the beams for the answer here. So here we have just 0 because we're not doing any logic here. When a beam comes through, we're just returning the beam as is, and we're not incrementing count. But if you imagine that for every row there was a split, we could do like state.count plus 1. And so that would increase that number and give us the answer we're looking for. This is saying that there's 15 rows, so there's 15 count, but that's not right. So what we want to do is we want to take the state, the indexes, and we're gonna see if there's any hits, if there's any laser hits. So let's start there with the state beams. I think set.map, take a single beam index, and we're gonna say is split equals set.member, the beam index, if we find that in our row.splitters. So remember, row.splitters is a set. So we're basically saying this is true if I found 7 in my set of rows. So it'll be false here, and then it'll be true here. If it is split, what I want to do is I want to say is split. Maybe I'll turn this into a list first. List.set.toList. List.map. split equals this. That'll tell us true or false. And then beam indexes, beams. This is going to be, if it is split, then we want to take this index, subtract 1. I think I just want to do set up on the list. 1. Otherwise, we don't want to split the beam at all. Set that from list, beam index. And so when I get to this part of the loop, this is going to be a list of these records. And so what I want to do here is I want to take those records. And I guess I want to list.fold again, huh? Count beam splits. I don't know what we're counting here. I guess we're gonna just have a inner count. Interstate. Interstate. We have 0 so far in this loop, and then the beams, it's just gonna be this again. The exact same thing. I just realized these types are totally the same. So we're gonna loop through, and we're gonna accumulate all these. Merge state. I guess the state is, what do? I kind of want to like, this is the state for just this fold. State from this row. The count is going to equal the state.count plus state from this row count. But the beams are just going to be the resulting beams from this thing. Oops. We're going to ignore these because we do keep it around if there is something. Because we do want to delete it. We don't want to accidentally keep beam index around. So sorry. So I'm going to format this. I'm going to try to format this. And then merge state is what we want to do to basically, when you have a state and a list of states, how do we do that? This is like the incoming, this is the existing. All we want to do is something like this. Incoming count, existing count. So we're just making a little helper here. And then here, instead of incoming count plus the beams, you can't add sets together, but you can do set.union, and that's going to kind of join them. Where were we at? Fold L, merge state. State is split. Oops, that's not what I think it is. All right, this is the inner state. And you know what? No, we can make this work. Let's call this count. If is split, then 1, else 0. That's what we're going to do. I guess I can move this into this branch. But whatever, this is... All right, I'm going to do it. I'm going to move this in here so that we only do the if statement once. And then I don't have to worry about having nested if statements. Does this look great? Cool. So if it's split, we say that we found one split, and the beams do that. I think that will give us 21. Sick. Okay, so 21 was the right answer for this puzzle input. So I'm gonna clear this, save this, and I'm gonna duplicate it so we don't lose what we have, and I'm gonna try it with my puzzle input and see how we do. 1570. Let's see if that's right. Move this over here. Sick. Okay, let's try out part 2. See if anything got crazy. Hopefully no. Maybe we can do this before my hair fully dries. Probably not. With your analysis of the manifold complete, you begin fixing the teleporter. However, as you open the side of the teleporter to replace the broken manifold, you're surprised to discover that it isn't a classical tachyon manifold. It's a quantum tachyon manifold. Oh, duh. With a quantum manifold, only a single particle is sent to the manifold. A tachyon particle takes both the left and right path. This is impossible. Many recommends the many worlds interpretation, tachyon splitting. Each time a particle reaches a splitter, it's actually time itself which splits. In one timeline, the particle went left. In the other timeline, the particle went right. To fix the manifold, what you really need to know is the number of timelines active after a single particle completes all its possible journeys through the manifold. Whoa. Okay, I feel like this is like I do a multiplication somewhere. I just have to use my brain. Every split creates 2, so it's 2 to the power of the count, right? No, is that crazy? Different timelines. Oh no, because it either hits or it doesn't. Got it. Do split. So I only do half of them. I feel like there's a math for this. I feel like, just like looking at this problem, every time I hit a splitter, there's kind of like our... Sorry, let me undo this. Every time I hit a split, there's like a left path and a right path. So I feel like the timeline count is the sum of the timeline counts below it. And so I just have to say, like, I think it's just recursion. It's like you picture these as all like miniature splits. So like, oh, sorry, let's look at the simple example. Like here, it's like as if S was here and we're just doing it again. And so then we just have to solve the smaller problem. And then we have to solve the smaller problem and solve the smaller problem and the smaller and the smaller and the smaller until we get here and there's one timeline. And you say 1, here there were 2, here there were 4, you know what I mean? That kind of thing. So I think we just keep deferring. We say like, my amount is that amount plus 1 or something. And then we just explore out left, explore out right, and then we sum that for both the timelines. But doing that in a stack safe way might be interesting. Okay, so if there's a hit, maybe the count doesn't matter anymore. I think timelines is, oh, whatever. We're counting timelines now. Let me see if I can get the right answer, and then we can see if we can refactor the code to be stack safe. I'm just going to try to get the answer here. So really what I want to do is, instead of count splits, I'm going to rename this to part 2. And I'm going to call information a tree. Well, whatever, information. Every time I hit a split, I want to basically create a new information and start at the top. So count timelines. So I want to gobble up rows from the... This is fun. Okay, this is weird, but it's trippy. Count timeline for row. We're going to do timelines. All right, the beams will always the beam will always ever go on one index. So this whole set thing. Beam. Okay, so we're gonna say timelines. Beam is only ever gonna be, there's only ever gonna be one beam. Rows. Info.rows. I need to know how many steps we did so I know what rows to ignore. So if I find a split, so this goes down, for example, here. And so in that case, it's just how many timelines are below. Count timeline for row. Count timeline for row. Is this the same? Is this right? I'm trying to think if this is the right way to start it. For a given row. No, I don't know if I want to do a full del at all. All right, here's what I'm going to do. I'm going to be a crazy guy. I'm going to delete everything that we ever did, except for this. This is going to say 6. Okay, cool. All right, let's start with kind of like, this is like a tree. This is like, I know this and I know how many rows I have. So each time I take a step, I think this is going to be info.rows. I'll say if there's, if there's no more rows, we're going to return, the number of timelines. So initially, is there 0 timelines or 1 timeline initially? Come back to that. That's a to-do. Should this be 0 or 1? This is a question that I can only answer after I write the rest of the code, so it's kind of weird. All right, so whatever. So we're going to give it the answer. If there's no rows, how many timelines are there? If this is empty, there's only 1 timeline. So I think 1 is the answer. Okay, if I have a first row and I have the rest of the rows, remember this is a set of indexes. So the first time we come through, it's going to be this empty list. What I'm going to say is if is split is something we can reuse from the previous answer. If this is split, basically if the info dot, I'm just going to call this beam instead of start. Doesn't matter there. That's going to do it. Okay, so if the beam hits a splitter, there's only ever going to be 1 beam. So there's going to be 2 possible timelines. So if there is a split, then what we want to do is count the timelines of zero. No, starting at timelines. Remember timelines, we sound so far. But this time the beam is going to be beam -1. That's the left branch. And then the rows are going to be the rest of the rows. I think that's right. What's weird is this timelines is like nested. So this is the part I'm worried about, why I'm a little stressed, is like, it's like, what I really want is this timelines And then I want to do it again, and this isn't tail recursive. That's like a functional programming problem, but or like a problem from us not having for loops. Although I'd probably run into the same problem if I did have for loops. Info.beam plus 1. So I want to count the timelines. This plus this. Do I need that to do that? I don't know if I'm doing this right or wrong, but whatever. So let's just keep it moving. No, there's no purpose in doubting yourself. He who hesitates is lost. All right, let's just get through this and then be confused. All right, so if there is no split, we are going to leave the beam as is and do the rest of the rows. We want to count the timelines. When would I ever increment the timelines is what I want to know. This is the part that is important. Timelines plus 2. Yeah, nothing ever increments timelines. So it's a split that creates a timeline. So let me just think this through. So 1 hits this, becomes 2. Let's just pretend this is the end of the line. One comes in. Just going to type beam 2 timelines splits into 3 timelines. So every split I hit, there's only ever one beam, so I don't have to worry about like, oh, adding up all of them. Should increment my timelines by 1, I think. So let's just do that. See what happens. Oh yeah, and I need to basically only change the rows here. This is like my input's messed up, but I'm just gonna copy the input from before. So this one said 40 different timelines. Oh, okay. Cool. Well, hopefully it's performant. I'm worried about blowing the stack because I'm doing this nested one. But you know what? We'll save that worry for if the browser spins. I'm going to duplicate this. Come on, recursion. Don't do this to me. Oh, I don't like that. Oh, I don't like that. It's a lot of stacks. 151 stacks. We'll be fine. That's fine, right? What's 151 stacks? Uh-oh. What's 151 stacks really at the end of the day? Wait, exit pages. I feel like I could just have 2 counts. The left and the right. How would I do it? How would I do it? How would I merge these? Oh, it kills them all, huh? 40. All right, cool. Well, good thing I saved. So this is the problem is that I have this nested timeline thing. I guess I could have a list of timelines. How about that? A list of information. Yeah, let's do that. A list of information. Infos. Let's see if we can get this to also say 40. And I'll say case. Infos. Oh, nothing. Timelines. I don't think we'll ever get to this case. How is this gonna work? No, this doesn't make sense. Maybe this makes sense. I gotta think about how I'm gonna unrecursive loop myself here. Count timelines. To count timelines, can I count the timelines of a list here? How would I do it? I'm curious if I only do one, what the number is. Eight. How do I get to 40 with 8? Well, this is fully symmetrical, so like if there was a dot here, this would be a different beast. Oh no, this isn't fully symmetrical. Interesting. Okay. How do I make it recursive? This is a little programming puzzle that I feel like I should be good at as a Elm developer. But how do I, at least I know what how to solve the performance. I'm trying to think of count timelines. The whole idea with this like tail recursion optimization thing is that it only works if you put this on the outside. So normally the trick is like, rather than saying 1 plus the result of this, you're putting the thing in that result. But if I nest count timelines inside of itself, what it's doing is it's like, okay, in order to figure out how to do the right branch, I need to do the entire left branch. And so it keeps looping and calling functions, and then the amounts of arguments that are getting added just keeps growing. So I need to figure out a way to do this without being a doof. Can I use a fold L? A fold L. I can't use a fold L with recursion. I can't call this again. So like the approach to reuse my logic and break it into smaller trees, it's going to be a problem. At first I thought I could do this. Is this the right intuition? What would it mean to count the timelines and be given an empty list? Like if this was a list, let me think about this a little bit more. Case infos of, if it's just one, we're here. But what would I do if there were two? What would that look like? Because in this case, there are two. I add one, and then I explore this, and I explore this. How would it work if I had two? First and the second. Let's be dummies. First. Second. I think if I can get this to work, we're good, because we know for a fact that I only ever call it 1 or 2. So all other timelines I can just return. Whatever the number is. It doesn't matter. I could return -1 here. Maybe I'll do that just for clarity. If I hit here, but I don't think I can. Okay, so if I did do first and second, how could I evaluate the first and the second? The first branch, this is the first info, so this is like first.rows. If this is split, I still think it's the same problem, because like I'll get here first. This one just explores. It should be like 8. It should be the first branch. Oh yeah. Sorry, that's a little cheat code. This is gonna only explore the first branch, but it does it in a tail recursive way. The second branch, I want to put it in here, but I can't use recursion. We're back to this problem. So that was one idea, is to split that. The other idea is to split the ints, but that doesn't make any sense either. I'll come back to that, but what am I going to do? It's the total reset. Maybe I work from the bottom up. Is that crazy? Like, to start here, be like, okay, for these splitters, collect the sets of numbers that would increment. I'm gonna do something crazy. I don't think this is gonna work. But if it works, I'll be pissed. That'd be awesome if that worked. Can I just count the ticks? Because then I'd be the dumbest guy. You know what I mean? Or I'm the smartest guy for getting untricked. Oh, wait, what? Oh, it's already a thing. What? You're down here? String.trim. Oh, it's this is complaining. Sorry. No. No, that doesn't make sense. Why would that work? That would be crazy if that worked. Okay, sorry. I was just being very optimistic. Don't make fun of me. I'm a simple man. String.lines. We're back to business. Back to information. Because like the whole thing is, I'm like, this is a smaller program. If I work from the bottom, what if I just trim out all the dots? Would that give me enough stack savings? Let me try this. I'm gonna refresh this, and I'm going to do string.filter. string.lines, list.filter, line, list.all. Take the line. We will say string.toList. That'll give me a list of characters. If everything is this, then I don't want it. Okay. Will this reduce my stacks enough? This will half my stacks, which I think scales exponentially, so maybe just get rid of the dots will get me out of jail, and I don't have to think anymore. That would be sick. Because these dots don't mean anything. They're just adding noise. Okay, I'm going to save this. Copy this. Leave. I give up on that. Give up on that instantly. There is a way to solve this. I think by just taking smaller steps and I think folding upwards and saying, was there a laser above me? If there was, add one. So I think I have a path forward if this doesn't work. And it probably won't work, but if it does, that would be hilarious. It's just crazy that like 70 lines, like 70 lines of code would do that. Okay, exit. Okay, so here's my plan. I've got my rows, and before we do anything, I've got my sets. So I can kind of loop up and say if there's any adjacent neighbors. Like here's what so the first thing I did was basically this, which I don't think is that necessary. But what I want to do is I want to say count the neighbors. Count how many times I look up. Okay, I'm gonna do this. Maybe.map what Ryan is saying. To thing Ryan is saying. I'm Ryan. And now I talk about myself in the third person. That's how messed up this is. I'm deleting all this. New approach. If I take the information, what I want to do is take the rows, reverse them. Let's just count this out and see if this is doing what I'm thinking. So starting with this, I want to do is list.fold L, the count, and the row. So we're just gonna, oops, sorry. The row is gonna come in and the count's gonna come in. 0. Okay, so we should get 0. Okay. What I want to do is I want to say, look at these indexes and look up and say, if there's a guy next to you, add 1. Yeah, like delete yourself and add 1 to the timelines. If there's not a guy next to you, let's say you're... Is everyone always next to everyone? Like you would basically be hit, so you're incrementing your timeline. All right, so let me just put this in code. If, shit, how do I don't know the previous row. I think I need an initial row. So the accumulator last. All right, we're gonna make another state. We're going to call it Hawaii 2.0. No, we're going to make a state that keeps track of the thing. And then we're going to say, case this is of, if there's at least one thing in here. So first row, rest of rows. Then we can do what we need to do. The rest of the rows, we start with the first row. That's our set. So we picture beams going upwards. And if they have a guy here, I don't know if this is going to work, but we're going to try it. I think I kind of want to like work my way backwards, and I think that'll work with a fold. If has adjacent, so this is the new row, and then this state has, let's make the type alias state equals count int, and the last row is a set of indexes. We are going to look through new row dot splitters, set dot from list. This will give me a list of indexes. List dot map beam index if set dot member beam index. How am I gonna do this? I kind of want to loop through these. For each of these, tell me, do I get a hit when I go left or right? I'll try that. For the state dot last row, do I get a hit when I go left or right in the new row? I don't know if this is going to work at all. I think I'm going to be crazy. That, this is the number of hits. And then what are the new rows? This doesn't make sense. I don't know how to manage the rows. I don't even know what I'm saying. Maybe I just need to look at a smaller example. I'm gonna copy what we have here. And then we're gonna do a smaller example. So what I'm trying to do here is say, timeline. There's one timeline, it splits into two. And then it splits into three. This should return 3. I don't know what I'm doing. I don't know what the new row should be. Let's just say that the last row is the new row. I don't think this is right, because if there's a miss, then I think we keep it. But if there's not, then we don't. So what are we doing? This is also nested in a terrifying way. Oh yeah, and then for everything else, 0 timelines, or -1 timeline. Oh yeah, that's dot count. Rest of rows. Do that. That's the fold. Where am I? Is this outside of the bounds of reality? Where this is that. Count is count. Fold is fold. That should snap over there. Fold L takes. I guess I can decide to fold L. But... What the heck? The rest of the rows. Oh, this is a list of reverse of a list of rows. No, that's already a list. Set two list. What? The new row is a row. This is why you never make lambdas, kids. You always need to annotate your lambdas. Because now I'm confusing myself in a big way. List dot map. Oh yeah, and this is sum of the mapping. Oh, that needs to go on the inside. Okay, we're gonna start annotating functions. That's what we're gonna do. Loop. Loop equals this. When you annotate functions in Elm, your life gets easier because you can let the compiler help you. The row coming in is a row, state is the state, and I need to return the new state. So let's see if this was what was wrong. Great. State.lastRow. State.lastRow.splitters. First row is a row. What the heck is a row? A row is a row. No? Oh, a row is a row. That was nuts. Okay, new row dot splitters. This can't be right, but here we are. Okay. Yeah, I just don't know how I'm going up. What I'm trying to do is I'm trying to collect a set of, like, if there's a laser above me, then there'll be a new timeline. That's like the high level thing I'm trying to do. Because I think that's right. It's like if there's a laser above me, there's a new timeline. Is the way I'm thinking about it. So let's go back to this. And count timelines still work? Ooh, count timelines. Did I delete it? I think I did. Reload. This is a bumpy ride. Okay. So this is 40. Let's just do this. Let me duplicate this again. Sorry. Okay, we've got 4 LE tabs now. This is 8. 7. 1 plus... Okay, so here's how I'm thinking of it. So let's just look at this example. This is a smaller example, so I think it's going to be easier to talk through. Okay, so we have this. In the beginning, let's just delete all this space here. I'm going to do a little trick for that. Oops. We can see clearly there are only 4 indexes, 0, 1, 2, and 3. Yeah, whatever, I'll keep those in. All right, so you've got 0, 1, 2, 3, 4. Okay, What I'm trying to say is that here my set is 0 and 2. And when I get to this row, I'm going to work from the bottom. I think that'll be easier. 0, 2. When I get to this row, how many timelines kind of like nothing happens? So like this should still say 0 and 2. And like this, the number of splits I found so far are 0. The number of splits I found so far are 0. When I get here, I am adjacent. I say for 0, I am going to give you a number if at this point there is like a line, basically. If there's a line here, you're going to get 1, and the only way a line will be here is if this is an S. Oh, did I get 0 here? Anyway, okay, let's just keep going through this exercise. I think this is helpful. I think I never ask if there's an S. So the only way, yeah, okay, so let me just go through. I need to get to 8, right? Or 7. I need to get to 7. So here, because it finds a guy to the right, it will be +1 if this guy gets hit. So what's weird is like it'll also be +1 if he gets hit. So I'm gonna like collect the 1s or the 2s. This is weird actually. I don't think this algorithm makes any sense. Because I only add 1 if this guy gets hit. It's almost like what the heck am I supposed to do? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. Sorry. 1, 2. They keep multiplying was the problem with my last algorithm. They kept just multiplying. But I don't think I need to be tracking stuff like that. I think there's a way to do this where I can't tell if the framing of part 1 is misleading me for part 2 or what. If this wasn't a video, I would step away and think about this for a little bit, but I'm kind of under time pressure, even though the video's probably been recording for a crazy amount of time. Because I got like insta-stumped on day 7, part 2. I'm like, do I have to completely rethink the way that I approached part 2, where I had the right algorithm but the wrong performance? Or is there some type of trick I can do to get the right, to make it give me that answer? And there is, like, what you could do is you could just run this program in smaller steps, because this is like completely decomposable. This is like back in the day, everyone was all excited about Hadoop. I don't know if you ever heard of Hadoop, but they were like, oh, MapReduce, like you can do your scaling, blah, 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 blah. And there was an elephant involved in the logo. But basically, the idea is if you take this problem with a really bad runtime performance and you break it up into smaller problems. It's like I thought this would work if I treated the bottom of the tree. I feel like this approach, there's something to it. I'm trying to figure out like what I am, like how to resolve this double counting fear that I have, which is that there might be something up the tree. But let's pretend that, let's say, just for simplicity, if you go up the tree and you see a neighbor, cool. Now become that laser going up, and every time that happened, you add a number. So this one got 1 for this thing, and it got 2 for this thing. I think at least in this simple example, this works. So then here, it happened 1 and 1 again. And then it happens, you find an S and you add 1, and this gets me 6. Oh, maybe I'm not counting like the multiplier. Oh, there's no multiplier. Zero and 2, it comes up. I will give you, maybe it's this plus the length. No, that's crazy. Yeah, maybe, no. What? I can't just add stuff because I like the shape. I can't just say the answer is 7, so add the length of this to 5. That's just crazy person talking. I go up the thing. I mean, yeah, I go up the thing. If there's an S above me, add 1. For everything to the right or left of me, add 1. So here I go. Is there an S above me? No. Is there a thing to the right or left of me? Does this work? Wait, does this work? How many S's are above me? 0. How many things are to the right or left of me? Whoa, 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 man. Could this work? All right, let me try it over. So I got 0 and 2. For each caret I find, I look up the tree. So we're just gonna work on each caret, okay? So what I'm gonna say is this caret is worth 1 point. Sorry, I'm gonna delete all this. Okay, the first caret is worth 1 timeline because it's adjacent to 1 caret. But this isn't true. It's only adjacent to this caret if the caret gets hit. But whatever. Let's try it. Let's see if it works. I don't think it will. How many carets? Oh, okay. I got a different approach. You start at the S. You go down. If your S hits a caret, so here my index is 2. I've got 2. I've got a beam going down 2. That becomes, so I got 0 splits. I got 1 timeline. I think this is my original algorithm. I'm going to get back to my original algorithm on accident. 1, 3, that's a split, so that's worth another. Yeah, this is my original algorithm. I'm going back. I'm going in circles. No, I'm not going in circles. I'm going to track. I have a single beam. It's 2. That's my beam. I'm going to track the adjacent carets. Adjacent carets, the indexes of them. I don't have any in the beginning. And then I'm going to say the count, so the number of timelines. God, I always do things crazy though. I'm like really doubting myself. I'm like, there's probably like a C developer is like laughing, or just a person that's not totally fried. Okay. One timeline, the beam comes through. What I do in my state that I'm keeping track of, so I go through here, I know that I have one timeline and index 2. No changes here, nothing happens. Here, because the 2 passes through a caret, I am going to say add 1 to the counter. I don't know what to do with this. I'm going to put a question mark here. It's 2, but I don't know if that matters. Okay, now I have 1 and 3. So what I do here is I say where any... Okay, does the beam pass through me? The answer is no. So that doesn't get me any points. But did I find activated caret? This is activated because I only add it to the list if a beam passed through it earlier. So basically, is there a guy above me? So for this number, I will say add 1 because, oh, I'm sorry, this is a caret at 2. I just realized that the S has no meaning, dude. Like, the S doesn't matter at all. So I feel like my solution's really simple all of a sudden. All right. We start with this, basically. Hits this thing. There's a caret at 2 that got activated. Because there's a... no, sorry, I'm getting confused. I'm going back to simple. The beam means, is there something directly under me? The adjacent caret activated thing is something else. I don't think this... I think this should be like a maybe. So we're gonna say that it's empty after it hits the caret. So what I'm gonna do is I'm gonna say, great. You get a point for every activated caret you are adjacent to. Caret. I don't know what I just said. So we have the 2. This guy gets +1. This guy gets +1. So we do 2 + 1 + 1 is 4. Because this gets +1. This gets +1. This doesn't matter anymore. And now the activated carets that I have are... It's like this. What's interesting is like, if the left side hits something, it's done. So like this caret shouldn't exist anymore. It's like, really, it's almost like I have a... Oh, okay. Okay, I'm going to say the right and the left beams for each of these. So you get a point for right and left. I think this is going to work. This is going to be the longest video in American history, but hopefully this works. What I'm going to say is the left beam for 2 is valid. The right beam for 2 is valid. Okay, so we're going to do that. And then because we're going to check right and check left. This one didn't see anything left. This one didn't see anything above. Sorry, this one did see something on the right. So that gave it a +1. And it removed it from this list. So I'm just going to say +1, remove the 2. And then the second caret came along, gave me a +1, and removed it from the left. And so now it does this, but it also inserts this guy, inserts, you get a point right left of me. So he's like, yo, because I hit something, I will insert myself. So like add L1, R1, add L3, R3. So at the end of this, this is what I have. This is like above. I'm just going to call this like above. And while we're here, I'm just going to do this like left, right. So because this found a hit, this hit on the right, it's going to add 1, and it's like, okay, great. I absorbed a beam, so I'm going to add myself over here. I'm going to add myself as an index for future people because there's no beam that will come from here anymore. The point you get for finding a 2 on the right, you don't get it anymore. I don't know what this formatting is. Sorry. I'm just going to remove R2, hit R2 means +1, hit, found 2 in the left +1. So it removes L2 and adds self. This one found this caret found hit A2. So it gets +1, removes A2, add L1 or L2, R2. Okay, so that's what we did. That's how we got there. So this is like what's happening because it hit A2. Great. So now we're here. This guy hit. It checked the left and the right. It didn't get a hit on the left. It did get a hit on the right. So this one got a hit on R1. That gives it +1 point. It removes R1. And it adds itself. L0, R0. Then the really interesting one is this guy. This guy when something gets hit, it doesn't matter because 2 things can't take up the same column. So hit L1, R3. It hit both, right? So like the right one did both. Because this had a L1, L3, and then all that stuff. So it's going to get +1 for that, and it's going to get +1 for that. So by the end of it, the total is 7, and that's the answer for this example. So more importantly, what it does, is it removes L1 because of the hit. It adds itself, and it is what, 2 again? Removes R3, so it adds itself. Right? I think it adds 2 of its No, it doesn't. Well, it should, because there's 2 timelines, right? Well, no. This is the part I'm not sure. Do I double add myself? Okay, that got 7. Let's add one more line here, just to see what the behavior would be for adding one more thing here. Will this jump up to 8? It should, right? Oh, 9. Okay, let's figure that out. Because I think if I can crack that code, then we're good. I love that I have a working implementation that I could test against, because I don't think I could calculate this. Like, I really lucked out. But anyway, so at the end of the day, we removed R1, L1, but we added 0, 2, 2. And then for the right, we added 0, 2, 2. So I'm wondering, for this guy, if it consumes 2 timelines, and we're adding the length. Like, if this was for this, oops, I guess I'll just do it, and I'll do it. Just hit L2, but because there's 2 in here, we get +2. It's not, we're not always adding 1, we're adding the number that we found in there. So remove the L2s. All these are removing all of that. Hit L2. Hit 2 L2s. So we remove the L2s. And how many of me do I add? Do I add as many of me's as there were? Let's find out. So my guess is, because I can just plug it in and see what the number would look like. The question is, do I add 2 L2s? Do I add 2 of myself? What am I, 3? And I feel like this should add multiple. But anyway, so this gets us to 9. And I'm just kind of BSing my way. So the 0 sticks around, the beam is still going down. That's the trait that I like about this, is that the beams that don't get consumed don't go away. So the left got removed. Left side. But I did add 3. So if I add a single 3, that's one thing. I feel like I'm going to end up adding 2. We'll see. And then to the right side, how many did I remove? Nothing. I didn't remove any rights. So I'm going to add one more example here. If this goes up by 2, if this is 11, I'm going to add many. It goes up by 12. I don't like that. I don't like that. Oh, it goes up by 12. Wait. This guy never got gobbled. Oh, wait, no. Never mind, I'm full of it. No, I'm dumb. I'm a dumb guy. What the heck is this, though? Yeah, because this timeline trickles through, you dig? Yeah. Okay. This should go up by 12. Wait, what happened to my... Where did this guy go? This guy had a 1-3 and a 1-3. He removed an R1. Oh, this is L1. Yeah, R3 should still be hanging, dude. Okay, that was my bad. That makes sense. Wait, what? What does R and L mean? I'm tripping myself up. Yeah, you get a point if there's a thing to the right of you. So this guy gets a point. Sorry, I need a... Don't worry about this. Okay. This guy hit an L3. He gets all the L3s. He gets points for all the L3s. I think at some point I mixed up my order, but I think this algorithm works. Let's start from the top. The S says you get a point if you are 2 and it's a hit. You do get a hit. You get it for as many 2s in this list that there are. So you get +1 points. Remove the 2 from A, and then add yourself left and right. Just append yourself to that list. Hit R2. Okay, so now we go down here. This first one hit. I think what's confusing is like I'm getting confused like left of this or right of this, and so my L2s and my R2s getting messy. But this guy hit the laser. He put himself in the left bucket, so the left laser gets removed. No, I'm gonna keep it like I found something to my right, so I'm gonna remove something from my right. So I'm gonna remove a 2 from my right. That gives me 1 point. And then I'm gonna add myself left and right. This guy is gonna remove a 2 from the left bucket, add myself. So we have 1, 3, 1, 3. Great. This guy comes along. He says, I'm gonna remove R from this column, from 1. That gives me 1 point because I only found 1, 1 in this list. I'm gonna add myself left and right. This guy is gonna remove the L1. Or sorry, this was the R1 I meant. They found an R1, removes the L1, removes the R3, he removes the R3. So at the end of the day, wait, what? I think this is where I'm getting mixed up. Remove the R. So I'm looking up, remove R1. Great. This one, looking up, remove L1, remove R3. This is L. This is R. This is R. This is going to help me remember what the freak's going on, man. So you remove it, but don't remove L3. L3 should never have gone. You still get a point for this guy. Because if someone later gets that beam, that's a point. Cool. That's where the 12 came from. So here, I get 2 points because I found 2 2s. And I insert myself here. You don't get anything. And, yeah, I insert myself twice. Yeah, I insert 2 copies of myself. So I'm just going to do this. This is like what gets inserted. One guy did that. One guy did that. Oops. One guy did that. And one guy did that. So I'm putting that parentheses. These are independent ads. Yeah. Okay, now we're fully confusing syntax. I think this is going to work. I know this is a 2-hour video. I'm sorry. I think this is going to work. It's going to work. This is going to work. I have too much faith in my stupid idea. Okay. Here's how it's going to go. I'm going to delete all these, make sure that this is equivalent. 12. Perfect. That should give me hit L3. I found 3 L3s. So I do that. I insert myself 3 times. This is great. This is great. To information. We're going to keep count timelines around, and we're going to just test different numbers. Maybe.map. Crazy thing. What are we tracking? Crazy thing tracks. Whatever. We're going to do the crazy. It's going to take in the information, and it's going to return the int. Info. We start from the top. So, info.rows. Rows, you already filtered yourself. That's the filter out the extras. Let's stop fold L. Crazy step. I don't know what to call it. But there's no state, which is great, so I can make my own state. Initially, above, so I'm going to do this in the same order. I have one timeline. Above is info.start or info.beam. I have no points for being on the left, no points for being on the right. It's important those are not sets because we want to have multiple copies. We could use a dictionary too, but whatever. That actually might be smarter. I don't know if I care. Do I care? This should maybe be a dictionary. Okay. Let's do that just because I don't want like a crazy long list to blow our performance. I like with all this work, I don't want to be like, and it's because I was lazy at the very, very end. I did all that brain stuff. Okay, so the count, let's call it timelines. Timelines is an integer above doesn't matter what this is. I'll make it a maybe index. It's kind of dumb that I'm even counting this, like, to be honest. It doesn't matter. The first splitter is going to get the beam, right? So yeah, forget this whole above thing. Genuinely, it doesn't matter. Whatever. I'm just doing it because that's my algorithm and I'm not going to mess it up. Okay, this is the good thing. We got this. This is going to work. Okay, maybe. That's just the above will say, like, has that beam been consumed? And then we've got the left is a dictionary, which says, for a given index, how many do I have? So I'm going to make one more thing. Alias count equals int. So this is just going to keep track of that. And I'm going to say add amount. I'm going to say index count. And this is just going to be a little helper that I write for this data structure so that my code is easy. At this index, this count, dict.update, that index, I'm going to get a maybe. There's nothing, that means it's 0. It hasn't found an entry yet. So what we're going to do is we're going to say just count. If there's an existing number, we're going to add that. Cool. Cool, cool, cool. Crazy thing. Got a comment out crazy thing. Crazy step. I'm hyped for crazy step. Okay, here we go. We have our rows. We're going through. We're chugging through all these splitters. I really hate that I put the splitters key in here. I'm going to take it out. A row is a set of indexes. Everything I did was dumb here. Don't know why I wrapped that in the record. I was wrong. I'm sorry. It's been confusing me ever since. Okay. Compile, it's angry because it doesn't know. Okay, it doesn't know a lot of things. Okay, just existing count. Great. What's a dictionary? Good question. I can answer that one. Crazy step. Awesome. Okay, here we go. Crazy step. Here, let me make sure that this is still spitting out the same thing. Date index count. Oh. Okay, still just 12. All right, I just want to make sure that removing splitters didn't cause me any troubles. Okay, so here we say 7. So 7 comes through. I'm so excited about this. This means that I'm gonna be free. This will not have recursion. It's gonna use a full del, and it's just gonna keep accumulating information. That's like that's the way to get out of a infinite loop. Okay, crazy step. We are gonna take in a single row, also known as a set of indexes. I'll call it a row. And what we have here is the state. I don't think I defined what state was. Oh, I did up here. Great. I was like, it felt familiar. I felt like I did. Cool. Row state equals state. Sick. Okay, so what we're gonna do is for each item, we are going to loop through each index, row set to list. Well, set dot full del. So we're going to take that row, and for each index, we're going to have the state. I'm going to call this initial or outer state, so I don't get it mixed up with this inner state. This should change nothing. Great. Great. Okay. All right, we're going to do a few things. State S. This is kind of a crazy, it's going to be crazy syntax, and I'm going to apologize in advance. If index, just index, equals state dot above. Then we are going to clear the above field and add 1. What is it? I'm just going to call this count again. S.count plus 1. That's just going to clear out the initial B. Otherwise, no change. Okay, now case dict.get index minus 1. If I subtract 1, I check the left. If I have a hit, what I'm going to do is I'm going to say, okay, this is like the amount of items I found. What I'm going to do is I'm going to add that amount. In the left dictionary, I'm going to remove. We're going to take this, the left. Oops, this is s.left. This is the danger of me doing all this nested stuff. I'm going to extract all of these so that I don't accidentally. I'm going to name this something that I can't screw up. See that? See, I almost screwed it up there. Okay. S.left. Oh, this is nuts. Okay. We're gonna add the amount here. That's where we get our plus whatever. +1, +1, +2, +3. We're gonna remove index minus 1. And then we're gonna add index the amount of times that we that we were passed through, the amount of times the laser passed through us. Otherwise, we're gonna do nothing. The unfinished parens somewhere. Where? Somewhere. Oh, sorry. Otherwise, there's no hit, no modification for the left. We're gonna do the exact same thing for the right. Oh, we're also gonna insert ourselves left and right. Sorry. So before I duplicate this, if there was a hit, yeah. Oh, and I didn't insert myself in this one. This is kind of silly, but I'll say s dot left add index 1. S dot right add index 1. So if a laser hits me, I initialize the thing, and this is a, if we missed this would have been devastating because I never would have found that. Here I don't want to remove from the right, I just want to add myself to the right. Okay, now I need to be very careful about where I replace stuff. If I find myself on the right, I do that, and if I find myself, and I add myself to the left, count is 8. Count is 8. Oh, am I adding correctly? Count is 8. What am I doing? I think I must have missed something small here. 12. Okay, cool. Count is 8. Above, left, right, dictionary. Date comes in whatever it was before. For each row we do this. What was this? Is this? No, this is right. I hit my insert. Okay, I want to print out where it was every step. I think 0 is actually where we want to start. Oh, this updates the right and the left. It should be right. Okay, so for every step, I want to say debug log. Row index. Row. Sorry, I'm trying to figure out how to do this. String.from int row plus row. I'm gonna do this. Here we're gonna print out the state at that. This is like the column. This dot what is it? Map tuple pair, index map tuple pair. And then that will make that a comma. Logs. 7. So it removes itself, it increments the count. Okay, let's figure this out. So it comes in here. It says there's one beam going down. Oh, sorry. When it inserts it, it needs to do it in the right spot. No, it's saying me. It's saying me. God dang it, I'm so dumb. So close. So close. Okay. Is this 9? Okay. Is this 7? Okay. 4, 1. I like this. I'm gonna save this. All right, let's try it with the original puzzle input. Please be 40. Please be 40. It's 40. Duplicating. I'm saving. I don't need to print out everything. I just need to do crazy thing. That count. Oh, please. Don't do, okay, I cannot be doing debug logs. That will fry my computer. That could have been bad. Oh, okay. There's my copy pasta. I told you I had to be careful there and I wasn't, and that's the cost of being a dumb guy, you know? This is like the target. I should have gave it a variable name. That would have prevented that problem. Okay. I like this. I like this. This is crazy. I'll leave the comment in there. Duplicate. Will it work? Please work. Oh. Oh. We did it. We did it. 2-hour video? We did it. I don't care. You watched it. You watched the whole thing. You probably didn't watch this. Who watched this? Drop a comment in the chat if you watched this. Even if you skip to the end and watch this part. We did it. That's it. That's a week of effing code. It was horrible. I think a year of spacing will be good to kind of, reset my brain for next time. But thank you so much for watching this year. I hope you all have wonderful holidays, Happy New Year, and I hope to see you next year, December 1st, to do this all over again. And hopefully we're a little smarter then. See how it goes. Goodbye.